morning. Sorry, good evening, everyone. Am I audible? Hello, am I audible?
Yes, sir.
So, in which week are we?
So 10th.
This is 10th.
Sir, 11 weeks, sir.
Yeah. Okay. So, just let me quickly search. Where is my week 11? So, how are you guys doing with your this course?
Okay, sir.
How are you doing?
Sir, good. Sir.
When is your exams?
29, sir.
Okay.
But until now, there are no upload the admit card, sir.
Okay. So, how's your preparation going on?
Sir, just as
Start
now.
preparing for exam?
Yes, sir.
Okay. So Arun is saying started preparation for
Sir,
exam.
sir, next week, your session and sir session also collide, sir.
Oh, again?
Again, sir, this third session.
Oh, okay. So you did you ask to sir in the last session that how would be the questions, like will it be the MCQ or the subjective?
Mhm.
Did you ask?
No, sir, because there is no option to interact directly with this, sir.
Okay. Okay.
The chat option is closed, sir. So how we can chat,
Oh,
sir?
then so what sir was doing? I mean, it's an interaction, right? So in interaction, you have to ask something.
No, whatever the question is, I mean, asking by the some student from the month within the month, then they will explain all the question like that, sir.
Oh, okay. So how many NPTEL courses are you taking?
So two courses.
Which one is the another one?
Another is composite materials, sir. Introduction of composite material.
So is there also session like mine?
No, sir. They only take class,
No
not live
any
session.
session?
No any session, sir.
Okay. So you guys are a PhD student, right?
You're right, sir.
In which, from where?
From NIT Mizoram, sir.
Huh?
NIT Mizoram, sir.
NIT Mizoram. And Arun is from where? Which college? And in which year are you?
Sorry, sir.
Okay. In which year are you?
Sir, first year, sir. First semester.
First semester.
Yes.
Oh, it means you have just started.
Yes.
Oh, okay, okay.
And this is my coursework, sir.
This is your.
Coursework.
So in your institute there is no course.
Sir, for my guide, they give me two NPTEL course for the coursework.
Okay. Okay. So this will go to your I mean main result. Is it like that? They will consider.
Yes, sir.
Okay. And
So
what are
this
what
result, this
what is your
result,
department?
sir, mechanical, sir.
Mechanical. In mechanical, what is your that like thermal design?
Design, sir. But here, specialize in mechanical, sir. No, any they took as admission as machine design like that. Simply mechanical.
Oh,
They take it. They intake as a mechanical PhD.
no any specification.
No any aspect.
Okay. Is also from mechanical. Okay. Okay. Yeah. Okay. So, how you are saying something? Yes. Somebody is saying something.
No, sir.
Okay. So let's start, guys. Our today's sessions without any further delaying. So, yeah. Good evening, everyone, and welcome to the week 11 of our sessions in the course of Techniques of Material Characterization. So, I hope till now you guys are doing well, and let's begin with our further questions. Uh, just like similar what we were doing till now, and so I'll directly put a questions in your screen in front of you. So our first question in the screen is the intensity of any wave is what? Proportional to the square of its amplitude, inversely proportional to the square of its amplitude, proportional to its amplitude, or inversely proportional to its amplitude. That you have to think. And
Yes, sir. Proportional to the square of its amplitude.
okay, so do you know the formula or what's the logic and how it is proportional? Or you just simply know and you're just saying? See, whenever you take any courses or any this, just try to clear your concepts rather than just knowing the concepts. Knowing is different thing and analyzing is different thing. So in your PhD that will work. PhD is all about analysis. It's all about analysis. It's definitely about knowing. If you know, then only you can design something further. But analysis is very important. Why I'm saying is you will get to know further when you will move with your results, when you will write a paper, when you will communicate, then how important your analysis part is. Because what you know is one thing, but you will never get, or most of the time you will never get what is your expected result. So it's always very important to analysis what you are getting and what's the reason and how you are getting the things like that. So there comes, that's why they're in a different companies or in a positions when you will see why they have the vacancies of a data analyst, why they require a data, a very particular person whose job is just to analyze the data, right? So that's why data analysis, analysis of your results, analysis of your any concepts, Analysis part is very important, especially in research sector, right? So since you guys are PhD, so that's why I'm also on the same page. So that's something which I have learned in the beginning of my PhD. Since right now I'm like in the soon I'll be completing, but that's why I'm saying this, isn't it? Did you get what I'm saying?
Yes, sir. Yes.
Okay. So yeah. Okay. So here when you will see this slide in the lecture, okay, so have you guys watched the lectures before this or for your assignment?
Yes, sir. Yes, sir.
Okay. So this geometrical construction may be avoided by use of the analytical treatment in which complex numbers are used to represent the vector. So here you will have it like this iota is what? Complex number, and this is your real number 1 2, and this is your iota 2 iota, this is your complex number. So in this is avoided by the use of analytical treatment in which the complex number represents the vector. So this is your vector. It is plotted in the complex plane in which the real number are plotted as abscissa and imaginary numbers are ordinates. So this is in the ordinates and this is in abscissa. Any point in this plane or vector drawn from the origin. So this 0 is your origin, and whenever you want to draw any vector you have to draw from here. It represents a particular complex number, okay, such as your, because this slide this coordinate or this axis is your real and this is your imaginary, so this will be your complex number. Here again the amplitude and phase of the wave are given by a. So this is your phase and amplitude. The length of the vector and phi, this is your angle, the angle between the vector and the axis of the real number. Now the intensity of a wave is proportional to what? To the square of its amplitude. This quantity is obtained by multiplying the complex expression. Now here comes the reasoning here. This quantity, how it is obtained? How it is coming to the proportional to the square of its amplitude. This is your amplitude, okay? Multiplying the complex expression for the wave by its complex conjugate, isn't it? So here comes the thing. So this geometrical construction, just the intensity of a wave proportional, okay? So here what will be this? So this is your x axis, this is your y axis. Iota value is what? Iota is nothing but root or minus 1, okay? And this value of this then when you will do this, so conjugate is what? This is, and a into e to the power I iota phi, and when you will do the conjugate multiplying by its complex expression, what will you get? This will be cancelled and then you will get a square, okay? So this is your formula, a sine 2 pi nu t minus phi, and this is a into e to the power I phi. So what's the value of this? This is formula basic in your 11th 12th you must be studied. The value of this is your cos phi plus I sin phi, okay? So here comes how it is coming to the square. The intensity of a wave is proportional to the square. So this is the intensity of a wave is proportional to the its amplitude, which is nothing but the a square. And how it is coming to square? When you will multiply the complex expression. So this is your complex expression by the conjugate. What is the conjugate? Complex conjugate is this, okay? So when you multiply this you will get the square of its amplitude. In this way you will get this. So the option A, proportional to the square of its amplitude, will be the right answer. So are you guys making a notes of these questions or the slides which I am showing, or how it is coming? If you want, you can write it down that how it is coming. It will be good for you to remember. It can come in your exams. This is exams question, and this is a very good question. It can ask in your exams. So just make a like very small notes, just so that you can remember.
Yes, sir.
Is it done?
Yes, sir.
Okay. Let's move to the next question. Structure factor is what? The wave scattered by a single atom of the unit cell, the resultant wave scattered by all the atoms of the unit cell, the resultant wave scattered by any two atoms present in the unit cell, the resultant wave scattered by all the unit cells. Yes, hello. What is it?
Sir, B.
B?
Yes,
How?
sir. Sir, sir, this is in the, I mean, in the lecture, sir.
Huh?
This is in the lecture, sir.
This is in the lecture.
Yeah, all the atom of the units.
So when you watch the lectures, so did you understand the whole thing? I mean, at least 60 to 70%, or you just
50%
watched
I
and
understand.
you got the answers and you just for the sake of giving exams, taking marks.
No, sir, I watched the video and after that.
Huh?
This is this question is also in the assignment, sir.
Hmm. Okay, let's see. We'll discuss. So what is a structure factor? So just let me quickly put it on charging mode. It's charging is getting lower. Yes. So adding the scattered waves from each of the atoms in the unit cell requires addition of the complex numbers. Okay, representing the amplitude and the phase of the each wave. This amplitude of each wave is given by what? Appropriate value of this amplitude which we discussed earlier is given by the value of atomic scattering factor. Okay, it is represented by F for the scattering atom considered and the value of sine theta by lambda involved the reflection. Now phase of each wave is given in terms of what? HKL reflection which is considered and the UVW coordinates of the atoms. So this is about the your planes and the axis coordinates. The resultant wave is scattered by all the atoms of the unit cell is called what? Structure factor. So this is the resultant wave is scattered. Okay, it's not individual. The resultant wave is scattered by all the atoms of the unit cell, not particular one or two atoms, by all the atoms, and it is a resultant wave. Is your structure factor. So the resultant wave B is scattered by all the atoms of the unit cells. So in the first awesome, a single atom of unit cell? No. Any two atom? No. By all the unit cell? No. It's a scattered by all the atoms of the unit cell. The structure factor is obtained by adding together all the waves scattered by the individual atoms. Okay. How it is obtained? When you have to add together all the waves scattered by the individual atoms. Okay. Now here you will see the adding the scattered wave from each of the atoms in the unit cell. It requires addition of the okay, so it is the same thing, but here you when you will see, yeah. So this is given by the sine theta by lambda, your atomic factor, and the formula for this is sine theta by lambda equals to 1 upon 2d. From the 2d sine theta equals to lambda, so it comes from there. It's the explanation. And the f is what your structure factor. Okay, so structure factor is given by what? Summation of n equals to 1 to n a e to the power I phi. Okay, when you put the value of phi, what is the value of phi? 2 pi h nu plus k v plus lw. Okay, it's come from here hkl and uvw. So you just put the value of phi to in this formula and you will get the structure factor formula. So this can be also asked in your exam, not the formula, but it could be like with the options that what is the correct formula for this. Okay. Now this structure factor, it is a complex number and it expresses the amplitude and the phase of the resultant wave. Now its magnitude or the mod gives the amplitude of resultant wave in terms of amplitude of the wave scattered by a single atom. Okay, resultant wave scattered by a single electron. Like the atomic scattering factor, it is defined as a ratio of amplitude. So what is the structure factor? Amplitude of the wave scattered by all the atoms of the unit cell divided by amplitude of the wave scattered by one electron. Okay, and F is what? Atomic factor. It is the amplitude of wave scattered by an electron, sorry, an atom with z electron by amplitude of wave scattered by one electron. Now, so F structure factor is n into atomic factor. So this intensity of the beam diffracted by all the atoms of the unit cell in any direction predicted by the Bragg's law is proportional simply to the f square, mod of f square, and this obtained by multiplying f with its complex number. So here this is your f, and this when you have to multiply this you will get this. Okay, so the formula of f, in this way you will get summation of n equals to 1 to n a e to the power I phi n. Structure factor is an important relation in X-ray crystallography since it permits a calculation of the intensity of any HKL reflection from a knowledge of the atomic position. Okay, so it is nothing but the resultant wave scattered by all the unit cell. You just note it down, this formula. This formula is very important. They can ask what is the difference between, or how this two, capital F and the small f, are correlated. Then you must be knowing this formula. This can be asked in your MCQ question or right question. This you should take down.
Hello, sir.
Yes. Note it down. Hello.
Yes, sir. Noted.
Oh. Now it is the again with the same question. Now it will be easy. The structure factor is a complex number which express what?
See, sir.
Both amplitude and phase of the resultant wave. Okay. Yes. So in this slide you can see the this is your structure factor. It is given by this formula, and in this formula you will have your phase also. Okay, amplitude and the phase. Okay, so this A is your amplitude and this is your phase. So this is represented by the both. Now for simple crystal structure, this is very simple question and it is very important. It can be asked not in your this exam, it can ask in any exam, in gate, in any exam when you will get. It's a very basic question of the material science. Yes, what is it? Yes, it's simple. See, this is a simple crystal structure. Okay, so in a cubic, there is a simple crystal structure, face centered crystal structure, body centered, base centered, and there are some many more like a diamond, cubic, and all kind of things. That's different. So in SCC, it depends on HKL, depends on H plus K plus L, independent of H, K, and L. Okay. So now when you will see, now you're gonna give me these answers. Structure factor calculation for simple crystal. Okay. Now can you tell me that what are the, can you see the diagram and tell me the what are the atoms, how many atoms are there in a unit cell of a simple crystal structure by looking at the slide? Yes, very simple. You must have watched the lectures, right? And it's very simple. I mean, it's not something rocket science. You can see the diagram and you can tell that how many atoms are there in a single unit cell.
Sir, one, sir.
Huh?
One by eight of the atom, sir. I mean, total atom of the simple crystal is one. 1/8 into 1 by upon 8 into 1/8. That is one atom, sir.
Okay. And how this one will come?
This eight atom is at the eight corner of the atom, sir. So 1/8 of the part. So that's
Eight
the
are eight atoms in the corner. Okay, perfect, excellent. And then how it will come to one?
sir 8 into then 1/8 part of the atom, sir. Every corner has.
So why we have taken 1/8 part?
So because it shares only 1/8 part of the corner, sir.
No, eight part of the no. Why we have taken eight 1/8? I mean, why it is coming 1/8? Eight corner is there. That is true. But one, this particular, let's say one, or so why we have taken the 1/8? That's what I'm asking.
So because 1/8 part of the corner, sir, for the whole atom at the
No, that
corner one by
okay. That
eight.
is also true. That is true. Now this is 1/8. So this one atom is will be shared with how many unit cells? That tell me. This one atom, can you see this one atom where I am locating? This can be shared with how many unit cells?
One atom can is with eight electrons.
Yes. Your voice is shaking, not coming clear.
One atom is shared with eight unit cells.
I think I can't hear you very properly. Can you write? Who was saying? Arun, right? I am asking that the one atom which you see in any corner is shared with how many unit cells and how? Okay, 8 unit cell is the right answer. Can you imagine that how it is shared with the 8 unit cell? Can you imagine? Yes or no? Yes. What about Afzal? Can you imagine how it is shared with the 8 other unit cell? The corner atom is?
Yes, sir. Eight corner of the atom.
No, 8 corner is fine. I am saying, can you imagine that the one atom in the corner is shared by the 8 unit cells? Did you get what I'm saying?
Yes, sir.
So, see, this one atom, one unit cell is this side, one unit cell will be in the front, one unit cell will be this side. In the top also, one unit cell in the top, one unit cell here, one unit cell in the top, and one unit cell here. So total it will share with the 8 unit cells. So that's why 8, there are total 8 atoms. Total 8 atoms, and one each atom is sharing with the 8 another unit cells. So that's why 8 multiplied 1 by 8 and it's coming to 1. Okay. So now when you will calculate this f, it will be the formula which I stated. That's why I said that note it down, the formula. F multiplied e to power 2 pi iota h u k v l w. U v w is what? This coordinate. So this is what? 0 0 0. So when you will take a 0 0 0, f is equals to f. So intensity is what? The square of this. And this is nothing but what? F square. Okay. So what question is asking? Structure factor is depends on HKL or not. That's the question. Okay. So can you see here and tell me now that whether it is I am explaining this much, I have given you complete the whole thing. Now can you tell me that whether it has, I mean, dependent on HKL or independent? Now can you tell me a little bit about this at least?
So for the structure factor, there is no, I mean, H and K and L. Sir.
Yes, excellent. That's what I'm asking. Because when you put the value of UVW, it it will become what? Zero. And e is to power zero, anything that comes to the power, it's one. So it's F. There is no HKL, isn't it? So that's why the answer is B. It is independent of HKL. That's what I said in the very beginning. The analysis part is very important than how it is coming. Anybody can tell that, yeah, it is very basic. When you will say anybody who is from the material science that whether the structure factor of the SCC, the simple crystal structure is dependent on HKL or what, they will say no. But very few can tell you the answer that why it is coming independent of HKL. Because of the coordinate. They knows the coordinate, but they did not know that how it will come, how they are correlating the structure factor to this atomic factor. Okay, so you should know this formula, that how we are deriving. That's the very important. Okay. Now just see, I will not explain this slide much. Just see that how the XRD comes whenever, because you guys are also working in the material science field. So you can see that how the XRD pics look, and just tell me that, about this, that how it looks actually. What are the pics they are coming? So just give a few seconds to just see the XRD pics and just uh, observe the what plane are coming in the XRD pics. Now, just now, like I have explained, I hope you have a pen and paper besides you. So right now, I want you to calculate and give me the answer of this. It is very simple. Like this is just as different from the simple cubic. It's a base center crystal structure having two atoms per unit cell, or even it says that two atom per unit cell are located in what? You have to give the answer of this coordinate, and it is very simple. You just draw and let me know. Yes. What did you get? Yes. What did you get? What coordinate? Where it is located? Okay. So if you did, don't worry. I'll explain it. So here in the slide, you can see how the atom is coming to two 8 atoms in the 8 corner, and this 8 corner atoms shared with the 8 other unit cells. So 8 multiplied by 1 by 8. Now 2 is there at the base center, and this will shared with the atom is shared with the 2 unit cells. So that's why 2 into 1 by 2, and 2 to cancel out, 8 it cancel out, 1 and 1. So now when you see here, this are where these atoms which are located at the corner. What's the location, or what's the UVW? 000. And what about this base center? This base center
Sir,
is
one what a half and zero.
1 by 2. You have to go x-axis in 1 by 2, y-axis in 1
Y,
by 2, and
Z,
0
Z
in
axis, Z axis.
z-axis. So this is your base centered translation, isn't it? So this is base centered, and this is a is not equal to b is not equal to c, and alpha, beta, and gamma, the angle is 90. You remember for this base centered. This is very important. Okay. So the option is 000, 1 by 2, 1 by 2, 0. C. Got it?
Got it, sir.
Yes. Now it's about the body centered crystal structure shows forbidden reflection when what? Which will be the correct? This is also very important question. These questions is can be one of at least 2 or 3 questions can be surely asked. This kind of questions are very frequently asked questions.
Sir, H plus K plus L is odd, sir.
Huh?
H plus K plus L is odd.
Odd.
Yes, sir.
Okay. Let's see. So, how many atoms are there in the body center?
Two, sir.
Huh?
Two.
Two. How this two will come? Can
Sir,
you?
1/8 into 8 is 1, and body center is almost is already 1. So 1 plus 1 is 2.
Okay. Very nice. Very good. Yeah. So it means it is clear. So it's a very fact that when you take a BCC, then this H plus K, I mean the H plus K plus L should be odd. So whenever you see the XRD peaks of your BCC, okay, this is your A is your sorry, B is your body center. So can you see like 110? So when you sum this, okay,
Okay, sir.
now this is body, okay,
Okay, sir.
yes. So this will be your odd forbidden reflection. Now the base center crystal is just shows reflection only when S plus K plus L even or unmixed mixed.
So H plus K plus L is even, sir.
Even.
Yes, just before you guys said that for the even, H plus K plus L is for the forbidden is odd, and for the, I mean, structure factor is not equal to 0 when the H plus K plus L is even.
Hmm. Okay. So yeah, in base center when you will see the H plus, yeah, the H plus K, sorry, H and K are unmixed. So here when you will see this is your base center, and when you will see this HKL, so these are unmixed. Okay, and these are the explanation that how it is coming. H and K are even, S plus K are even, and it is unmixed. Both either it could be odd or even. Okay, so here whether it is like when you will see 111, so this is both are odd, 11 odd, odd. Okay, when you are seeing 0 to 1, these are both are even. So yeah, these are like unmixed. Body center crystal structure having two atoms per unit cell are located where? Now it is very simple. You can, no need of pen and paper, you can directly answer this.
Sir, A answer is A.
Yes. So now you got it. How it will come? This is 0, 0, 0, right?
Yes, right. Sir.
X direction half, Y half, Z half. You will reach to body center.
Yes, yes,
Okay.
yes.
Now for FCC shows reflection only when.
Sir, C answer is.
Okay.
Sir, sorry, sir. HKL are mixed, sir.
Okay. Yes, so it is for the phase center. So for the phase center, when you calculate by a given formula, this is structure factor. So what it will come, it's HKL are unmixed and it is even or odd. So your H plus K on K plus L plus H is even. So when you calculate this, so HKL will come to your mixed and 2 even plus 1 odd or 1 even plus 2 odd. So H plus K or K plus R or L plus S will be odd. So HKL will be your mixed. Okay. Sorry, HKL are unmixed here because this is for FCC, right? So for FCC it is unmixed. Here you can see H plus K, K plus L, L plus H is even. So in your structure factor, when you calculate the F, it will come to your 4F. How this 4F will come? You have to put the value of H, K and L to this formula. And from where you will get the H, K, L? From here. Okay. So it will come this and this is unmixed and yeah, H plus K, K plus L, L plus H. When you will see for this, it is even. This for BCC it's different. For FCC this is. When you will see 111 H plus K 112 even, K plus L is also even, L plus H is also even. So this is for FCC. Now a structure factor and crystal structure, this is very important. This is what I wanted to show. Just note it down this table. Simple. This is all. Base centered H and K are unmixed. Body centered HKL are even. Face centered HKL unmixed. Okay. For reflection necessarily absent. So here in the question it was asking that shows reflection. So that's why for the FCC it is HKL, yeah, are unmixed. Okay, because here the reflection is present. And if it is absent, then it is mixed. HK plus is odd. For the body centered, H and K are mixed, and for simple it is none. Just note it down this. It will be very important formula and table.
Hello, yes, sir.
Yes, note it down.
Yes, sir.
Okay, just a second, no? Just a minute. Yes. Now, NaCl crystal structure shows reflection only when. Now you can give the answer for this very quickly.
Sir, answer is mixed. Yes, sir.
A.
Yes, sir.
Okay. So NaCl is what?
Sodium, sir. Sodium chloride. This
No,
salt.
I am asking the crystal structure.
Uh, Sir, crystal structure is for the sodium octahedral. Sir.
No, the eight. I am asking the atoms arrangement. Octahedral is positions where the atoms
Yes,
are
sir.
positioned. This is phase centering translation, and so are the chlorine atoms positions. Okay, so whenever a lattice contains common translation, the corresponding terms in the structure factor equation can always be uh, uh, factored out. So here this is the same as like your FCC. So in FCC, what we have seen, this is the structure factor. So FCC is what? Just you see, shows reflection. So it's saying the reflection. So HKL are unmixed. So option B is the right answer because in FCC HKL are unmixed when reflection is possibly present.
Sir is explaining that HKL is unmixed. Sorry, HKL are mixed.
Mixed is when reflection is not present.
Yes.
So in the question you just see it is asking shows reflection. Just read out the question.
So that's why, no, this.
Huh?
Yes, sir. Yes.
That's why it is HKLR unmixed. Now NaCl crystal structure possess what?
Yes, sir.
Yeah. So what is A?
More than four atoms per unit cell, but the lattice is phase center.
More than 4 atoms per unit cell. Okay. So here when you will see this is the Na positions, this is the Cl's positions. Okay. So When you will see this, this will be like um, more than when, because this is the face centered. The face centered is also 4 atoms in a unit cell. So Cl is also present. Okay, so more than, but the lattice is face centered. You can see these are, when you will consider the Na, this is corner and these are the faces. So it's just like a very simple face centered. Multiplicity factor for 100 planes in cubic and tetragonal crystal structure are what? 6 and 4, 8, 2, 2, 8, 4, 6 for 100 plane in cubic and tetragonal. Yeah. So in the multiplicity factor for 100 plane is for the cubic crystal is 6 and for the 1 plane is 8. Okay. And for the tetragonal, the 110 planes do not have a same spacing, so the multiplicity factor for 100 plane is reduced to 4. So for cubic it is 6 and for tetragonal it is 4. Okay, in this slide you can get what is multiply and how it can be calculated. So it is nothing but a proportion of planes contributing to the same reflection enters the intensity equation by multiplicity factor. Okay, and there are different planes and corresponding to the different planes. For the cubic, if you will take a 111 plane, then the this factor will be 8. For 100 it is 6. So it is nothing but how it is, I mean, coming 600. So it's a relative proportion of planes contributing to this that particular reflection enters the intensity equation as a multiplicity factor that you have to calculate. Okay, so yeah, and here also for 100, this is sorry, for 100 planes it is reduced to 4, and the value for 001 planes 2, it is corresponding to 2. So 6 and 4. Multiplicity factor for 001 plane, just I have explained. 001 planes is 2. You can see here 2. Okay, now as a result of increase in temperature, what will be the answer? Intensities of the diffraction line remain constant, intensities of the diffraction line decreases or increases, or the background scattering decreases.
Sir, answer should be A.
A,
C.
intensities of diffraction line remain constant. Okay.
No, no,
So
C,
this
sir.
is, so increase in temperature, so the intensities lies of the diffraction line decrease, whereas the intensity of the background scattering between lines
Lines
increase.
increase.
Okay, so
So
it is
the
asking about the intensity of the diffraction line which will decrease. So option will be the B, not A. Okay, so this is the how it is dependent on the temperature. So you can see in the slides the explanations are there, and these are the how it is coming, the particles before it and after it, what will increase the kinetic energy, vibration, expanded space between the atoms and the vibrated around the fixed position. So that's why from here it is like a before heat and after heat, when we increase the temperature, so the diffraction line decreases. Okay, here also this is the coming because of the temperature, so intensity of a diffractor beam decrease as the temperature increases. Okay, so yeah, this is some questions for week 11, and that's it for today's. And yeah, let's meet in the next class. Okay,
okay, sir.
next portion will be covered in the next class. Yeah, goodbye and thank you.
Okay, good night, sir.
Yeah, good night.